In the last video, we talked about hydrocarbons and benzene. Hydrocarbons, as well as benzene, will appear as parts of larger molecules. So we'll summarize in the last video with a definition of hydrocarbon functional groups and how they're often represented in a larger molecule. We sometimes have a huge chain of carbons in a molecule, like the one circled in blue in the molecule drawn. But what if I don't want to show this part of the molecule? Or I want to focus on the specific group circled in green? Organic chemists have two ways of doing this. We either represent a carbon chain or an alkyl chain with the letter R. R is like saying blah blah blah, but specifying that the blah 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 is an alkyl chain. Sometimes we want to say blah blah blah, but don't want to be specific with an alkyl chain. In this case, we can use a squiggly line. Often you'll see the squiggly line in a bond line formula. We're going to be using R and squiggly lines a lot during this chapter and the rest of this course. Sometimes we use them interchangeably. But all you must know is that when you see R or the squiggly line, we mean blah blah blah, and you shouldn't focus on it too much. We talked about alkanes, alkenes, and alkynes, and hopefully you practice identifying them and naming them. If I showed you this molecule and asked you to circle all your functional groups, you would show this. We usually don't consider alkanes a functional group, since they're so common. Consider it like a default, and the rest are deviations. Alkenes and alkynes, or double and triple bonds, however, are considered a functional group. Most professors want you to circle only the carbons involved in either of these bonds. Also, remember that for an alkene or alkyne to truly exist, the carbons involved must be hydrocarbons. I want to emphasize that extremely loudly. This will come up as a point of confusion further in the chapter if you don't pay attention to this. Whatever you take notes with, put a star on this and drill it into your brain. Again, the carbons involved in alkenes or alkynes must be hydrocarbons. The last thing we talked about last video was benzene. Well, we mentioned it because it's a functional group. Well, it's two. Let's break that down. Say we have these two molecules. You may notice one big difference. An oxygen attached to the carbon right next to benzene versus an oxygen attached to the carbon over one. This represents two different functional groups that involve benzene, phenyl and benzyl groups, respectively. A phenyl group represents a benzene ring attached to other groups of atoms in a molecule. A benzyl group represents a benzene ring attached to CH2, which could be attached to anything else. When differentiating between the two, it may be easier to remember benzyl groups first. If the carbon attached to the benzene ring is free, or CH2, we have a benzyl group. If the carbon attached to the benzene ring isn't free, we have a phenyl group. We often show these two groups with our squiggly line. Hopefully you can see the difference. A benzyl group has one carbon attached to the benzene ring, while a phenyl group, the benzene ring doesn't have a carbon before this squiggly line. We also could show the phenyl groups as pH, or the Greek letter phi, or also C6H5-. We could also show benzyl groups as Bn, or C6H5CH2-. If you had to circle to show either one of these groups, you would only circle the ring to show the phenyl group, while you would also circle the CH2 to show the benzyl group. In this video, we defined alkyl groups, alkenes and alkynes as functional groups, and benzyl versus phenyl groups. In the next video, we will move on to our next functional group.